Hello everyone, welcome to this video. This is intended to be the first of a series walking through the FreeBSD Handbook here. So, this is what you get if you look up FreeBSD Handbook. It's pretty ubiquitous. But yeah, so the background for this is that I'm an electrical engineering student, and I'm really interested in operating systems, and I want to get deeper into learning how to use them, learning how they work. And this is really nice because it's like a well-known guide on how to use a particular operating system that's known to be pretty well built and stable. So I'm hoping to go through this. And yeah, like for context, I'm currently on Debian. So Debian is really nice, also nice and stable, but it's Linux. I don't know if there's as good of a kind of documentation as this, as good and cohesive as this. My personal favorite is Arch Linux, so they have an amazing wiki, but again, not as much of a kind of cohesive documentation. So if you want to look something up, like, let's look up Arch wiki. So if you want to look something up in the Arch wiki, such as like Xorg, it's really easy to find, and there's really nice documentation. So again, one of the nice things about FreeBSD is that they claim that their documentation is also amazing, and yeah. So the reason I'm doing this, I know there are some other FreeBSD series. If you go to YouTube and look up FreeBSD, right? Look up FreeBSD. There's some videos on how to install FreeBSD handbook walkthrough. Like, I think this is a series that it's up only 3 parts right now. Maybe it'll go further. This is 3 years ago. But it goes through some of the first parts of the FreeBSD handbook. And most of the other videos are just how to get started or like very particular things. But I was hoping, because maybe this handbook is a little abstruse for people to read. I know it was for me. That I could create some sort of like cohesive, hopefully complete or more complete walkthrough. I know I won't be able to finish everything because I might not have all the particular hardware that it deals with. For example, like maybe it talks about certain drivers for hardware that I don't have, but it might be interesting to do that. Yeah, so this might involve a lot of searching. It's mostly meant to be documentation for myself, in case I want to revisit this in the future, but I'm hoping it can help other people. So it might not be the most straightforward tutorial, but it'll show the learning process. Okay, so let's get started. Let's just walk through this. So I haven't even installed it yet. I'm planning to run this in a VM, and I'll show the setup. But let's get started right from the beginning. So what is FreeBSD? Preface. Okay, this is a preface to this handbook. Let's go straight to the introduction. What is FreeBSD? Okay. Well, welcome to FreeBSD. What's nice about FreeBSD is that it's open source, and it has a good networking stack. It's integrated with CFS, which is a pretty good file system. Very secure. It has a lot of security features. It has a number of pre-built packages, and I'll say this is good, but it's not the best. So I have tried to use FreeBSD in the past as my main setup, but that hasn't worked so well because it doesn't have some kind of basic features such as I think it doesn't have its drivers are not as well developed as they are for Linux. Linux is much more user friendly. For example, I know the NVIDIA driver, for example, doesn't allow sleep mode, which is kind of strange. But when you're in a server, it doesn't really matter. And there's iffy stuff with Bluetooth support, and it doesn't support all the like Linux already doesn't support a lot of the programs that are built for Windows only, which are used in a lot of professional contexts. And the support for FreeBSD is definitely going to be even lower. For example, for me, it was with Microsoft Teams. I don't think there's a FreeBSD port. And so I'd use the browser version, which is not terrible, but it's not amazing either. Documentation. So there's the handbook, and there's additional documentation built in, like there's HTML files in the file system, which is kind of nice. Simple and consistent repository structure and build system. Yeah, this is nice as well. So it's pretty straightforward. It's well built. Staying true to the Unix philosophy. This is interesting because I guess it stays closer to the initial init.d structure rather than like Linux branching out into a more complex and user space based thing, operating system, which makes it I guess Linux became more complex and it has a lot more pieces in it now, but FreeBSD is simpler, and that's another good reason it's good for studying. And then of course, since Linux is more popular, it's nice for things to be compatible between FreeBSD and Linux. So, I mean, it tells you about what things it can do. It's generally, it's basically a general purpose system, so there's not much that you would expect it not to be able to do. Like, it can run like a server, and I guess this is probably its main use now. It can be used, this is my purpose as education. I'm a student of electrical engineering, similar to computer science, or somewhat close to computer science. Good for researching, networking, embedded, desktop, software development. Yep. Okay. So who uses FreeBSD? Okay, I mean here on list of companies, it's not used that much. I mean the main one I think is probably Netflix. You can see Netflix Open Connect appliances are responsible for delivering more than 30% of all internet traffic in North America. So a third of the internet traffic is built on Netflix, which uses FreeBSD for most of the servers because their networking stack is that good. So that's nice. And then there's an additional set of other products. Personally, okay, so I've been using FreeNAS for the last 2 months for my NAS, network attached storage. So it's been super stable. I get an uptime of 90 days before a power outage, and yeah, and nothing broke. It was all good. GhostBSD is like a more user-friendly version of FreeBSD, and of course there are other BSDs as well. Like there's OpenBSD, which is more based on security, and NetBSD, which is made to be like super portable. And it's like anything can run NetBSD. I think there was a story of someone who ran NetBSD on a hard drive just by itself, like using the hard drive controller as the CPU, which is amazing. But okay, I won't go too much into the history. This talks a little bit about the history and like licensing and stuff, and the project goals. But in general, it says that the goals of the FreeBSD project are to provide software that can be used for any purpose and without strings attached. So it's like it's free in a very wide sense, I guess. Not only free in terms of the cost, but in its purpose as well. You can do whatever you want with it. And then I'm not going to go into this either too much. This is about the development model. And then third-party programs. Okay, so yeah, this is important in terms of the handbook. The handbook is located in the system itself, so you'll be able to locate it there and be able to open it with a web browser once you have it installed. So there's that. And then there's an FAQ as well. So let's go through the installation process, and hopefully this won't take too long. But I haven't even downloaded the installation file yet, but that shouldn't take too long. So what I'm going to do is to run this on a virtual machine. Of course, you could run it on a actual machine, and that shouldn't be any different. But just for testing purposes, I'm running it in a virtual machine. And again, this shouldn't distinguish it too much from actual hardware. Most of the time, you don't have to worry about minimal hardware requirements. If you are running in some sort of small embedded environment, then that might be a concern. But if you have like a typical PC, even from maybe decade or 2 decades ago with at least a gig of RAM, or I mean preferably 4 to 8 gigs at least would be nice and make it run snappy, as well as a multi-processor configuration. But even a single CPU processor and a like a gig of RAM should be enough to run FreeBSD. So yeah, I mean, and it also runs on a number of popular architectures. So for most people who are running Intel AMD processors, you're either running on a 32-bit or a 64-bit processor. So I mean, currently I'm running on a i7-2600 with 8 gigs of RAM. So yeah, this should be fine. Let's go to the download page. So I'm gonna download this now to just get started. So I am running on AMD 64. This is the installer, and this will come on the next page. But I'm gonna install the. I mean, for me, it doesn't really matter which one I'm using because it's it's in a virtual machine. But it depends on whether if you're gonna burn this to some disk, then this is for CDs. I'll go to the next installation tasks. Okay, so it tells you if you want to burn it onto a CD, then you can use this file. If you want to burn it onto a DVD, which has a little more space, you can use this file. If you're going to burn it onto a flash drive, not really burn, but if you want to copy it onto a flash drive, you use this. And you can use a utility like unit-bootin on Linux or Rufus on Windows, or just DD on Linux. And then these two, the mini memstick and the boot only, are minimal images, so they have really small downloads, but during installation it's going to have to download additional stuff from the internet. So what I'm going to do is, I mean, for me again, it doesn't really matter. I'm going to just use the memstick image. I'll download the compressed one, so it's the download will be a little faster on my end. Let's see. So, yeah, this might take a minute. Oh, that'll take a little while. I'm not sure why my internet's so slow, but I'll let that download. You can continue going through this, or I can pause the video. So here, it goes through the steps. I'm not going to go through this because there are many tutorials on this, but in order to actually save it onto the hard drive, oh sorry, not save it onto hard drive, save it onto some installation media like a CD or DVD or USB drive, there are certain steps you can do. But again, in a virtual environment, if you're running this in a virtual machine, it doesn't matter. You don't need to actually do that. Starting the installation. Okay, I'm going to pause for now and come back once the download finishes. Okay, so there goes 10 minutes, but it's finished installing, or sorry, finished downloading, and my internet connection is not as fast as I thought. But yeah, so the other thing to do now is to make sure there's no corruption. So we can download this checksum and check it against the actual file. So I mean, let me just, so I'm going to do everything in this folder. Oh yeah, I have also created a hard disk file, where I created a file that's going to act as a hard disk. And I mean, the command to do that was, oh, I don't want to redo that. Hopefully that didn't overwrite, or that might have overwritten it. Okay, yeah. So I guess I'll just do it again because what this is doing is generating a file that is 32 gigabytes to use as the virtual hard disk for this. So yeah, I mean, this is gonna take another minute, so I'll let that run on the side. But in the meantime, let's do the checksum. So first move the files from downloads. Let's see, what was it called? FreeBSD and downloads checksum. See here. Okay, and we see that, yeah, we can check the checksum. So let's calculate the checksum. So this is a SHA-512. So SHA-512 sum FreeBSD. Let's just do that to checksum. So just calculating the checksum right now. I don't know how long this will take actually, but we'll see. Oh, my bad. I have to. Sorry. First, I need to decompress the file. So this might also take a little bit. But if we have a compressed file, I mean, if we had downloaded the non-compressed version of the file, we wouldn't have to do this step. But since my internet is slow, I rather would download the compressed file than the non-compressed file. Okay, here we go. So now it's decompressed. So let's do ls again. So you see it without the .exe. Let's calculate the checksum again. So SHA. Oh, sorry. .exe. Okay, so let's recalculate the checksum, and it's going to store that in CS. Okay. Okay, so now we have this. So let's just make sure the checksum matches. So div checksum and CS. There's some div. Cat. Oh, we only need to check it against the correct one. My bad. So if we look at the checksum file, there are a number of ones here. So we can check it just against the memstick image. So right, and delete all of the rest because those are not part of the checksum. Okay, now let's do the diff. There's still an error. Okay, that's annoying. Oh, my bad. This is kind of silly. Let's just let's just edit these again. So and then dim checksum. Just get the checksum part. So yeah, okay. Now let's do the diff. Okay, and it gave nothing. There's no difference. Okay, that's fine. Meanwhile, this just finished. I'll just run sync just to make sure it worked. Okay, so now if we look at this folder, we see we have the, checksum we can delete now, but because we ensured that they're the same. We have a hard drive that's 32 gigs, and we have a 1 gig installation drive. Okay, so for the actual installation, I'm going to be using, to actually run it, I'm going to be using FreeBSD. Sorry, not FreeBSD. I'm going to be using KVM, which is an emulator or a virtual machine emulator in Linux. And the front end to that is something called the virtual machine manager. So if you're not familiar with KMU or KVM, right now I'm using the Debian in Debian, so you have to install these packages. It's similar in other distros. Like I know ArchWiki has a lot to say about this. You can look at these pages and look at how to install them. It's not too bad. You can install a KMU package. There's also the virt-manager. So virt-manager uses the front end, and that's what this window is right here. So let's create the actual thing. Let's actually do the install. So yes, this is a AMD 64-bit, AMD 64 architecture, and we're installing from a local install disk. So let's add this FreeBSD, and the FreeBSD. This is the installation disk. FreeBSD. It's FreeBSD 12, but it doesn't really matter what we call it. Let's give it 4 gigs of RAM. Let's give it all our CPUs. Yes, we'll enable storage. We'll use this just raw disk. Documents, FreeBSD, and then FreeBSD.raw. This is again a 32 gig drive, and yeah, I mean we can just use the default device. It doesn't really matter. That should work. Let's customize it before I install. I think often the topology for the CPUs is strange using this. So let's manually set the CPU topology. Yeah, manually set the CPU topology to just a single socket, but 8-core CPU. Otherwise, it thinks it's really weird. It treats it really weirdly. Most OSs don't treat the multi-socket CPU correctly. So we'll just set it to this. Let's apply those 4 gigs of RAM. We could give it more. We have 8 gigs here. So we have the virt-IO disk. We have the CD. Yeah, and I think it automatically installs. Oh, it's treating this as a disk, but we don't want it to treat it as a disk. Let's actually remove it, re-add it as a let's see, USB host device? No. Let's add a storage. Yeah, we would call it storage, and it would be like a disk device. Yeah, I guess. Oh, USB. Yeah, okay. Well, I mean, I guess it doesn't really matter what we call it. And then let's choose the image. Okay. Just so that it doesn't think it's a disk. I don't know if it'll really matter, but I think this might be better. Yeah, and the rest of these should be fine. Let's try begin installation. Oh, let's shut this down. So if we go to boot options, yeah, so the USB disk is the install disk. So let's try that. Okay, so I found the bootloader. That's good. Okay, and then here we see the iconic it's called FreeBSD loading screen. So let's just press enter. So in the meantime, I'm gonna put this on the right hand side here. I'll move this out of the way, and I will put this here. So let's continue here. So we've already started the installation. We don't need this page anymore. And I'm assuming that most people are going to be using AMD 64. And yeah, so we're at the screen now. So we can choose from these options using the arrow keys. But let's just do the install. And oops. Okay. Sorry. Choose a host name for this machine. So let's call it something like for me, I'm gonna call it something like John FreeBSD .local. So usually this should be like a fully qualified host name, but I mean this computer is not gonna be on the internet or anything, so it doesn't really matter. So yeah, I mean this goes through. I just did continue with the default key map. I set the host name, so you can make it really you can pretty much make it whatever you want. It should be like a host name though. So I made a job FreeBSD.local. Selecting components to install. So that's where we are right now. If we want, let's install all the options. So depends on whether you're going to use 32-bit compatibility libraries. Actually, I'm not going to install that. The ports tree I am going to install now, just so that we don't have to install them later. Source tree also install now, and then the test suite, sure. So what it's going to do is try to download some files from the internet, and so it's going to need to set the internet. So it's going to try to set it up using DHCP. Just let that run. Yeah, okay. So I mean, there's that. If we do configure IPv6 for the interface, it's up to you. I guess I say sure. Sure. It's not really too important now. But we'll let that run. Okay, so resolver configuration 192. Yeah, okay. Let's just leave it as it is, and use the default. Okay, here you can choose from a few different options. I'm going to use UFS now for simplicity, and go with auto, so that there's not much to do. You can say, okay, use the 32 GB disk, and let's use the entire disk. I mean, unless you plan on using like other operating systems and stuff, most of the time you can just use the entire disk and there's no real problem. Let's use GPT. It's a little more modern than the MBR, unless you have a reason for using MBR. And okay, so this is the kind of partition layout it's going to generate. Okay, so so this is just the drive that's booting off right now. You don't have to worry about it. Wait, actually, no. So this is the virtual hard disk. This is the drive that's being booted off right now. So it's going to partition this drive into a 512 kilobyte boot region, and then most of it is just going to be loaded onto the UFS, the main partition that's going to be mounted at the root, and the rest is going to be a 1.6 gig swap space, and it automatically chose that space. I'm not exactly sure how it chooses that. Yeah. Okay, so let's do finish this, commit. Okay. I mean, so here it gives you some techniques on choosing how you want to partition the drives. And if you want to use ZFS, which is more advanced than UFS, but it will probably give you better reliability, better speed if you're doing things on a large scale and have enough RAM, because ZFS does a lot of caching. Then yeah, go ahead with using ZFS. But for now, again, simplicity's sake, I'm using UFS. Yeah, I think most of this is for ZFS. Okay. So the next part is it's downloading the files that we need. So yeah, this shouldn't take too much longer. And then it'll extract them. Yeah, so okay. So look at this next section while we're waiting for this. We can set the root password, set the time zone. These are just localization options, I guess. Set country, confirm time zone, select date. These are the same as just installing any other operating system. I guess this is a little more interesting. So local unbound is for caching DNS entries. So unbound is a DNS resolver. SSHD is allowing you to SSH into this machine from other machines over the internet. MouseD allows for your mouse to work. So in the terminal it's kind of funky, but it does work on the console, which is, I think, it's kind of interesting. It's different than what Linux has. I don't think Linux has any equivalent. But it also enables your mouse for the GUI. So when you use the GUI, you have to enable MouseD as well. So might as well enable it. NTP date and NTPD. I believe NTPD is the NTPD like replaces NTPD. So I don't think you need both. I think you just enable NTPD. PowerD is adjusting CPU frequency dynamically supported. Might as well turn that on. And dump dev allows you kernel dumps, the kernel crash dumps. So again, it's not a bad idea to include that unless you really don't care for that debugging information, or if you don't have too much space or something like that. So yeah, okay. So we move on to the next step, fetching distributions and validating them. Soon, I guess it'll be extracting them. Okay, yeah, it's extracting them now. Here are some security options. So, I mean, it describes them here. You can hide the processes running as other users from unprivileged users. You can hide groups. Processes running as other groups from other users. You can hide processes running in jails from unprivileged users. So basically, if you don't want like unprivileged users to not see what other users are doing, you can hide them. You can do things like randomizing the process ID of newly created processes, clearing the temp file system on system startup, disabling syslogd or the mail service. You can give a password prompt on the console, and disallowing dtrace. I'm not exactly sure what dtrace actually is, but yeah, I mean, you can look at this man page, for example. Right? Dtrace is a dynamic tracing compiler and tracing utility. Yeah, so I guess this gives you some more introspection into how programs run. And if you don't want people to know how those programs run, you can disable dtrace. Yeah. So yeah, I mean, there's a lot more information here, but that's the gist of it while we're waiting for this. And then, of course, you don't really want to run most programs or use root for most things. Although I think we're probably going to end up doing that just as we're setting things up. So you can add additional users. So what FreeBSD has is this nice add user script or add user command, which is a little different than in I think Linux. Default is like user add. So I mean, if I look up the Arch Linux users and groups, I believe there's a command called user add. Yes, user add. Yeah, and it's not as easy to use as the add user command in FreeBSD, but it's basically the same thing. There's also the groups add. Yeah, so those are the two main commands in like Arch Linux at least, and I believe it's pretty similar for most of the distributions. Yeah, so user add is used for most of the commands. Here, okay, wait. Yeah, we got to the step where we have to add the root password, so I'm gonna enter it in. Okay, and then choose the localization. So I'm in the United States, America, Eastern, yep, November 23rd, yep. I believe that's the right time. Yep. And let's turn on this. Let's turn on the mouse. Let's turn on NTD and power 2. Sure. And then these I don't care too much for. Just skip these. And let's. This is where we're on. So let's add a user. So I'm gonna call it John. My full name. And there's a bunch of defaults you can leave. Default shell, yeah, sure, sh. Default directory home John, that's okay. Default, use a password, use a non-empty password. Don't use a random password. Enter my password twice, and don't log it up. Okay, so this creates a password using mostly defaults. So, oh, okay, I already. Final configuration, I accidentally clicked OK, but there's nothing else to do. We should be able to exit. So, oh wait, we could have installed the FreeBSD Handbook. Let's see, actually. Yeah. We set the time zone, we set the hardening options, the system security options, we just didn't check any of those. Set some of the services on boot. Set up the network stuff. I mean, that was set up when we were installing packages. Set a host name, set the root password, and then we added a non-privileged user. Yeah, the only thing we didn't do is install the handbook. Again, that's not really a huge deal. We're reading the handbook right here. It's not hard to access, but you can install it into the file system as well. And then, yeah, let's reboot. So let's not open a shell. So this is going to reboot the system. So right now it's shutting off. Let's see what I want. I might have to disconnect the drive. Let me check. Yeah, actually, let me just shut this down and disconnect the installation drive. Or I guess I don't have to disconnect it. I'll just disable it for now. Save this configuration, so that's going to boot from the actual hard drive, and make sure that works. Okay, yep, so let's do OK. So now FreeBSD is installed, so we're all good. Yeah, continue to let that run, I guess. So, okay, so here, there's some information about configuring the network interfaces. So, I believe this is still talking about the installation process. And I mean, for me, it's easy because this is just hooking up, like through a virtual machine. It's basically through Ethernet, and an Ethernet connection is pretty easy to manage. It was pretty much automatic. Didn't have to do that much. But if you have more advanced network configurations, you can set them up here. I don't have too much to say. I know on a laptop it's a little more complicated usually because of you have to set up the Wi-Fi. You have to set the IP address. If you want to set it to static. If not, you can just use DHCP. You can set the subnet mask. So like this depends on your network. Most of the time it's 255.255.255.0. And then the router, the gateway, like I don't know, it depends on your network again. For me, it's like 192.168.0.1 or 1.1. But again, it's up to your network administrator. And yeah, set up DNS. If you have like some custom name server, I mean, most of the time you don't, and your router does the name server for you if you have like a standard consumer router. If not, you could try setting your name server to something like 8888 for Google's name server, which is usually the upstream server for routers anyways. But yeah, okay. Let's see, troubleshooting, I mean, I don't think there's too much we have to troubleshoot here, but they mentioned if your system doesn't boot, sometimes it's due to ACPI, which is I believe a power saving interface. ACPI. Advanced Configuration and Power Interface, yeah. So this is used when your computer has pieces like the monitor shuts off when you close the lid. Stuff like that is due to ACPI, and sometimes that can inhibit the booting. So that can be something that causes your operating system not to boot. But they also mentioned maybe make sure your firmware is up to date, like your motherboard, for example. But in our case, everything's all good. This is in a virtual environment. It's not that hard to set up. Okay. And then here they also mentioned, like, I don't know if you remember, but when we first started the install disk, there was an option to use a live CD, and we didn't do that. We just went straight to the installation. But the live CD can be useful if like your system gets bricked or you accidentally mess up the boot partition, and the rest of your system might still be good, but you can't boot into it or something like that. So you can use the live CD to help repair that. And they say like, oh, it requires authentication. The username is root and the password is blank. Yeah, okay. So let's go into the basics. I mean, let's log in and just look around a little bit, I guess. So there's a nice welcome message here. Yeah, so this message is in etc message of the day. So if I want to do cat etc message of the day, then it shows this exact message. So that's not a surprise. Stuff like that. So I mean, other things we can do ls. There's nothing in this folder. wd, I'm in my home folder. Like do things like, what shell am I using? I'm using the very basic sh shell. Let's see if I can connect to the internet. I can. So that's good. And what else could I do? Not really sure right now. So let's just look back at the handbook. So this chapter covers the basic commands and functionality. So this is like the basics of FreeBSD. We're in chapter 3 already, which is kind of nice. And there's a lot in this chapter, but it's good information. So by default, you'll see something that looks like this on startup, and that's what we saw. And then I logged in with my login credentials. So the message of the day we already saw is in etc/etc/MOTD, and depending on the shell, you might see a prompt that looks something like this. So our shell looks like a $, or it's like the user at the location, like, where you are right now, and then the shell prompt. So there are, just like in Linux, there are virtual consoles. So this is the system console, the first console, TTYV0, and then there are 7 additional ones, and then the 8th one is usually reserved for the graphical interface. So just like in Linux, you can try Alt F1 through Alt F8. So, but actually, I believe Alt F1 through F8 are these 8, and then I think Alt F9 is for the GUI. If you're in a graphical user interface, when you're using Xorg, then you have to use Control as well. But I'm gonna try that. So right now, I believe I should be in Alt F1. So if I just press Alt F2 and I get this. Alt F3, Alt F4, 5, 6, 7, 8, and Alt F9 doesn't do anything right now. But it will, I believe, if, it doesn't do anything right now. And if I had Xorg installed, like a graphical interface, then Alt F9 would do something different. But now let's I mean, these are all the same. I went back to Alt F1. Go back to the regular system console. Yeah. So yeah, it says you can also edit these. Like, so let's. I'm just gonna cat out TTYs, okay, and it shows pretty much what you expect. Same thing. If I wanted to, I could like delete one of these. Like, oh, yeah. So say I deleted one of these, then it wouldn't show up when I press that key combination. It's not too important though. So then it mentions these man pages. So I guess if you're not familiar with man, then it looks something like you do man1 KBD control and read more here about how to keyboard control and configuration utility. Yeah, and then man1 vid control. And this helps you manage the system console. So basically what we're just talking about, all these consoles. You can change like the mode. So I guess this is the resolution, kind of. So foreground color, or background color. Actually, I kind of want to try this now. So how do I do this? Foreground. So vid control yellow blue. Or vid control show. Let's try vid control show. Ooh, this is nice. So vid control, this is probably look terrible. Yellow blue. Ooh, interesting. Okay, so we can do stuff like this. I don't know if this will affect other consoles, but let's try this. Let's go to a different console and do vid control yellow blue. Yeah, it does the same thing. So, oh wow, okay, so now the whole console is blue and yellow, which is actually not terrible. It looks okay. Hello world, we're yellow and blue. Okay, so what I'm gonna do is, oh, actually, it's still there even after you log out. So, okay, but I'm gonna go back to the first console, full screen, yellow and blue. Okay. So you can do stuff like that. You can look at these different ones. VT should be virtual terminal. Syscon, I don't know. Let's look at these. Man at KBD. AT keyboard interface. So I think most keyboards, AT is like a keyboard layout that most keyboards follow. And you can change the keyboard map and stuff. I'm not too sure about how keyboards work, so I'm not going to go into that. Also, man, syscon s console driver, sysconsole, okay. Oh, you can change more settings, like font. I see pixel mode. So if you're interested in that, and then man VT, so the terminal console driver. Virtual terminal console driver. So as opposed to the system console. So I think a virtual terminal is like emulating the system terminal. It'll like send commands to the actual system console. But yeah. So the system console I believe is TTYV0, like what I'm in right now, and then the virtual terminals are like the additional ones. So you see actually here, yeah, so this one I believe is the system console, and then everything after that is a virtual terminal. And if you open a terminal in your GUI like this, right, this is a virtual terminal. It's like basically like sending commands to the system console, but it's not actually the main system console. Not that the distinction really matters in most cases. Okay, though. Okay, single user mode. So if you saw in the boot screen, I'm not going to go back to the boot screen because this is not typically something you would do. But if you have a problem booting into your system, which I've had sometimes, if you can't boot into your multi-user mode, like for example, say you edited a startup option that is impossible and your system doesn't boot because of it. Like say when it's starting some sort of service or like trying some network configuration that just doesn't work and it hangs your boot or makes your boot not work, then you can boot into single user mode, which disables some things, and you should be able to boot into it. I'm not honestly sure why it's called single user mode. I guess the idea of users doesn't really exist anymore. It's just it's everything's like in root. And yeah, so the important thing is single user mode can be accessed by anyone who has physical access to your computer, which is an important thing to note, because when you boot into your system, you always have that option for single user mode. I don't know if there's a way to disable it, and I think disabling it would probably be bad, because then you can't fix your own problems. But because of that, anyone who has physical access to your computer can get root access to your computer and do whatever malicious things they want. So you always want to make sure if you have like a server, it's secure physically as well as like the network or whatnot. So, yep. Changing console video modes. So, the default here, I don't know what it is. I'm assuming it's 1024 by 768, but it can be adjusted. So actually, yeah, we're looking at it through bit control mode. Actually, can I try KLD load VESA? Okay, let's do sudo. Oh, okay, this is another thing. Okay, so let's go into root. For now, we'll install sudo later, but let's do KLD load VESA. Oh, VESA. I'm not really sure what that means. So let's check the message. I mean, okay, so this is the same message as that just happened. But I believe that what happened is that it's already loaded. So I don't know if there's a, let me see if I can do and KLD load, if there's a way to view the already loaded options. So there's KLD stat. Let me look at that. KLD stat. KLD stat. So these are the loaded modules, I guess. So I mean, let me try this again. KLD load VESA and look up this. Oh, let me do that and look up this error. I guess I can't. I don't know how to exit this. Okay. So KLD load VESA model. Error 6. Okay, so now we go to the FreeBSD forms for the first time. That part of the handbook is a bit old and needs an update. It assumes you're using SC, while recent FreeBSDs have switched to VT, System Console versus Virtual Terminal. And the most recent FreeBSD releases already have VESA included in the generic kernel. Actually, yeah, let me see. Oh, so that means rather than as a module, VESA is already loaded. Let's see. FreeBSD check if VESA is loaded. But I believe that yeah, okay. So it's like, I guess, so your kernel can have modules built into it, and sometimes there are loadable modules which are not built into your kernel, but you can add them as like on top of your kernel. I know like drivers, for example, are examples of modules, and sometimes you can load them. I was dealing with that in Linux when I was writing my own driver. So, but if it's already built into the kernel, I guess it doesn't show it up in this list when you do the KLD stat. So I guess these are just the modules that are loaded on top of the kernel. But if it's already built into the kernel, then I guess I can't do anything about it. But that's fine. It's good. We already have it built in. So I guess that's why we can already do vid control. And let's try changing the mode. So let's do vid control. Let's do man vid control again, right? See mode. Mode number. Okay, but let's say we wanted to make it. Let's see what's the largest here. There are not many here. Let's make it like 132 by 50, just something random. I don't know what it is now, but let's see if we can do vid control mode. Okay, it doesn't let us know what it is, but vid control mode. Let's do 132 by 50. Okay, maybe I did it wrong. Vid control. Well, we could do -I mode for find info about the mode. But I guess actually it might just be as simple as vid control. Well, let's do vid control -I mode. Okay, it doesn't tell us anything. Vid control. Let's try 132 by 50, and that did something. Now I don't know what it did. It made the text red, but let's change it back to yellow and blue. It's kind of strange, but I guess they interpreted that as a color foreground and background color somehow. So unless we can get it to recognize that, I'm not sure how. Okay, I mean, that's not a huge deal. We can also try the example in the handbook, vid control mode 279. Yeah, okay, and it does the same thing. It turns the text red, but I like the yellow blue. Okay, and then, oh, that's not so bad. Okay, so users and basic account management. So this goes back to the install stuff. It allows multiple users to use the computer at the same time. We can look at the, okay, let's see, account types. There are system accounts, user accounts, and the super user account. So I don't think any, like besides, okay, so the super user account is the root. There's only one of these. But between system accounts and user accounts, there isn't any real technical difference. It's just in like what kind of attributes they are given, and they're used for different things, but it's mostly a semantic difference. So system accounts are used to run services such as DNS, mail, and web servers. The reason for this is security. If all services ran as the super user, they could act without restriction. So in other words, what a system account is like a specialized user to run some sort of application, because when you set executable files or other file system permissions, you set them per user or per group. So if you want like a certain user or a certain set of users to be able to access a certain file or be able to execute a certain file, then that means that you should put them all into the same user or group. And again, some of the common ones are daemon, operator, bind, news, and www. So like if you have an Apache web server, it might be under like the www user, I believe. This one's interesting. Nobody is the generic unprivileged system account. However, the more services that use nobody, the more files and processes that user will become associated with, and hence the more privileged that user becomes. So if like, okay, I believe, yeah, so nobody should, I don't think this will work. Yeah, okay. But if I do cat etc password, and let's grab the nobody. Yeah, so there is, oh, I can't exit out of this. So you see there's this user called nobody, who's an unprivileged user, doesn't have a home directory, doesn't have a shell, but you can assign permissions to, you can assign files, you can like let files be owned by nobody or something like that. It's a general system account that can be used for running general processes. But in general, what you would be doing is creating user accounts, like for you and your members of your family, or like if you're in some sort of enterprise environment, the users in the company, right? So yeah, so each user account on a FreeBSD system has certain information associated with it. The username, the password, UID, the group ID, the login class. This one I looked into. This is just an additional method for allowing things like resource limits. Like if you don't want the user to use too much CPU, or actually if you don't want the processes of a certain user to use too much CPU or memory or stuff like that, you can look into that. Most of the time, I would assume that's not a huge issue, but if that's your use case, then you can set these specific permissions here. You can make it so that the password gets changed every now and then. I know some companies force this on other systems, maybe not at the OS level, but at other system levels. Account expiration time. So they give an example, if like say you're a student account in a school, it should expire once you graduate, or I guess that's up to your policy, but it can expire up after the students graduate, and so you can set it. You can set their expiration time, full name of the user, the home directory, which is where they go when they log in, and then the shell, which is the program. Like right now we're seeing the sh shell. There's also like bash or zesh, different shells that you can use depending on your preferences. And yeah, so we can. Oh, and then the last type of user we mentioned is the root account, which is used for managing the system. So right now I'm on the root account because the John account doesn't really have any permissions, so any real permissions. So yeah, let us. So if you wanted to switch to a different account, what you could do is use the su command. So if you want to look at the man page, this for a substitute user identity. So if I want to do su John, then I after doing that, then I look like John. Let's see, where am I? And then /root. But now if I wanted to do something privileged, like change the password of root, then it's gonna say permission denied. I can change my own password, but I don't want to do that right now. And I can do anything that John does because I'm basically acting. It's basically like I logged in as John. But yeah, the other way around doesn't work. So if I log in as John and try to su as the root, by default if you just do su, it'll try to log in as root, but it's the same as that. There's that. So let's use sudo. Let's install sudo. So just to show you how you can elevate your permissions and become the super user. And this is very common in Linux. I believe it's pretty much default. I mean, it might not be installed by default. Actually, I think in more recent versions of Arch Linux, it's not installed by default. But you can definitely install it, and this will give an introduction to the package system. So let's go to the root user and do package. And the first time you run package, it's going to say the package management tool is not installed. So let's install it. You're going to need an internet connection for this. and what it does is it basically installs the command called package. And then let's do package install. Actually, we might have to do package update first, just to update the its built-in repository metadata. Okay, and then let's do package install sudo, and press yes. So it's installing sudo. Okay, so sudo is installed now. That might be most of it. Let me try. Okay, so oops. Let's sudo as John. Oh, let's do. Let's try to sudo su or sudo su. Okay, I think this is gonna fail. Yeah. So what you have to do is also give John the permissions to be able to sudo, and let's look at the let's go back to the root user, and then let's do let's edit the sudo-ors file. Oh, it's not there. Wait. John is not in the sudo-ors file. So I don't know if I have to create the sudo-ors file. Let's try this. Man sudo-ors. Okay, default sudo security policy plugin. So, sorry, it's default in user local etc sudo-ors, or optionally in LDAP. LDAP is if you're using some sort of like enterprise-wide authentication protocol, like if you need like the same kind of authentication across multiple platforms or programs. So let's actually edit that file then. Let's do pi user local etc sudo-ors. Permission denied. Oh wait, who am I right now? I think I'm John. Okay, yeah. So let's just go back out. Let's do vi let's call etc. Oh, sorry, user local etc sudo-ors, and we can see here these are oh wait, must be added using vsudo. Okay, well, let's do that instead. So vsudo vi-sudo allows us to edit the sudo-ors file, and we can make it so that a certain user can so let's say uncomment to allow all users of all members of the group wheel to execute any command. Okay, so let's do that. So the reason I'm doing this is because we can give the user John we can add John to the group called wheel, and to do that, let's look through some of these first. So this is all related, I guess. Managing accounts, what you can do is use the add user command, which you've already seen in action once. I'll show it again. Remove user command, change pass command, which allows you to change some of the user details really easily. The password command, which I believe is actually kind of similar. We'll see exactly how they differ. And then the pw command, which is more flexible than any of these commands and has more options, but these are easier to use. So, for example, if we wanted to create a new user, let's do that. Let's create a new user and call it Bob, something like that. Just add user. So it's called Bob. Full name Bob user. Again, we can leave the default UID, default login group, default oh wait, yeah, there we could add Bob to wheel or other groups if we wanted to give them administrative privileges. So like wheel is like the administrative group that can call sudo. Login class default shell, default home directory, default home directory permissions. Let's say no password and don't log out the user. And then okay, actually I'm not going to save this user, but this is just a demonstration to show how to create a user. and you saw that in during the installation that was used. Similarly, you can do remove user, and you can add a username like John. Actually, yeah, let's remove John for now, and then well, actually, no, it's not. But you could do something like remove user. I'm gonna cancel out because I don't want to delete John right now. So remove user does that. Like it does a series of steps. So it's you want to call this command when you're removing user, rather than like just deleting their home directory stuff, because there are a few places where the user is like installed. Right? Change password. So we can look at the change password command, see what it does. So it shows you can change some of your user information. A full name. I think this is always funny. I don't know why. Charlie at, or I don't really understand this. Charlie at Charlie root is the name of the root user. Also, this password, I guess this is a password hash. That's kind of interesting. And yeah, you can set other information if you want. The default shell is C for the root user, I guess, not sh. And yeah. So what I could do is, because I want to set the group for John to wheel, let's try this. I actually don't. Is there a way? Group. Oh, group ID. So let's I'm not sure how this works actually. I don't know what this is actually supposed to be. So let me try wheel here. Invalid character. Re-edit, yes. Okay, wait, so maybe this doesn't allow you to set additional groups. So you usually have a primary group and additional groups. So I'm gonna leave that as is. And then there's also the password command. So let's look at, password is just to change the password. We already saw that. So if I want to do password John, then I could change the password to John, but I'm not going to do that right now. And you can another thing to do is look at the pw command. So this is the most fully featured of them all, and you can see there's a ton of options here. So what we are looking for is the option to add a group. So we could do pw group add. Actually, no, this actually creates a new group. That's not what we want to do. We want to do pw. We want to modify user and add a new group. So let's look at user mod, right? And just scroll down just to make sure we're understanding it. So actually, -g group sets the primary group. -g group list sets the additional groups, and we want to add John to wheel as well. So note that so it says the user is added to the group specified in groups list and removed from all groups not specified. So you want to make sure you specify all the groups, not just ones that you want to add. So in this case, we can first check which groups John is in. That's fine. So this is the primary group. It's not additional groups. We want to add an additional group. You do pw user mod John actually -g real John. Maybe this comes first. Okay, so now if we look at groups John, okay, John is also in the wheel group. And then if we, that's not what I want to do. Let's do sudo John. And we do the sudo su now. Yeah, it works. So I can go into the root user because John is in the wheel group. So I can run which things as John now. So I'll go back to using John in a moment. The other interesting thing is, you see it said you have mail when I log into the root user. So if I log just back into the root user like this, it says you have new mail. So let's check our mail. These are funny because what this is saying that John is a user that's not in sudo orders. Try to use sudo. And same thing here. It happened twice. So, yeah, okay. Let's log in as John now. So John can use sudo. John is a man user and can use sudo, so that works. Mission accomplished. And you could do other things like create new groups or manage groups using the pw command. Use ID to determine group membership. Oh, so this is interesting as well. So let's just try ID John. Yeah, okay. So this also shows groups. I guess it's similar to groups, the group command. Yeah, so the historic, if you look here, the historic groups command is equivalent to id-gn user, and then the who am I command is equivalent to id-un. So ID is more generic than either groups or who am I. Actually, I've never known about ID until now, but I have known about these two commands. So if I do who, or actually who, it shows your who's currently logged in. Who am I just shows your login username, and then groups shows which which groups you're in, or you can do groups like a different user. Okay. Yeah, the other thing is you can also look at group, so singular. So let's do let's do man group. So this shows you what the group's permission file looks like, which just gives a little more information. And so I guess two relevant files are etc group. So this lists the list of groups and which users are in those groups. So for example, the group John includes just the user John. I believe that's how it works. And you can see like different groups have different users. Like the nobody group has just the nobody user, I'm assuming. Yep, and there's also the password file, so you can do cat etc password, which does not list the user password, but it lists the different users and and some information about them, like their shell and their home directory. So there's that. You can see the nobody users here, as well as myself, the one that I created since I created last. Like all these are other system users that I created beforehand. They exist before my user in the password file. Okay. The next thing is permissions. So I don't want to go into this too much because it's the same as in Linux, and it's kind of common knowledge. You can look this stuff up easily. But in short, every file in the file system has a set of permissions bits associated with it. So I can do this by going to like a place that I know has files, and you can see there are different permissions over here. Right? You see read, write, execute, read, write, execute, read, write, execute. Where there's a dash, it means you don't have that permission. And the first is the user. The first group is for user. Second group is for the group, and the third group is for other users. And again, that can be explained elsewhere. Additionally, there are three other bits called the set UID, set group ID, and sticky bits, which are more obscure and less often used, but they can be used for certain circumstances. And I'm not going to go into them now. But yeah, this is good if you understand file systems a little better and file system permissions. I think this is really useful because I don't know if it comes up, or this isn't emphasized as much when you study Linux, and I think this is one of the things that differentiates FreeBSD from Linux, is that FreeBSD sticks more closely to this hierarchy that's defined here. Linux is a little bit more freeform, and they add additional directories on top. Like I know the opt top level file system is used often, and then there's like the proc file system, which is I don't think required in FreeBSD. So many of these you can see already just at the top level. So right now I'm already at the top level. and just by doing ls, you can see some of the some of these, like yeah. So we're at this just explains some of the meanings of these directories, and it's good to stick to these just to follow the convention. What you can do is also get this by doing man hier, HIER, and you get the same page. It's like the same description. But so what the root, you just go to the root, is the root directory of the file system. It's where everything else is stored under. The /bin is used for pretty much fundamental what's called user utilities. There's also a /sbin, which is for system programs and administration of utilities. So just to see what kind of programs are in both of those. I guess the distinction is not too important, but I feel like sbin are usually for even more fundamental programs, and bin is for pretty fundamental programs. So let's look at sbin. Sorry, ls sbin. Right, and you see some of these commands like gpart is a common one. It's for partitioning disks, and the 5's for like creating like what's called checksum or something like that. You see some IP tools like for internet access. I'm assuming swap on for like turning on the swap device. Mounting. Let's see. Stuff related to like backing up a file system like dump. Stuff related to file system checking FSCK. Stuff related to more file system stuff like unmounting, ZFS, the file system related stuff. So these are all like pretty fundamental utilities. On the other hand, if we look at /bin, right, we can see other things like, I'm actually not really sure what this command does. Condition evaluation utility. Oh, so I guess this is just a part of a shell syntax. I always thought this was part of a shell syntax, but I guess it's like kind of a command in itself. There's that. But let's select this. Yeah, so the commands like dd for copying disk blocks. Sh, which is a shell. I guess some shells are here. Sh is a shell. pwd for printing out where you are. Rm for unlinking stuff. Set ACL. Set file ACL, pkill. So none of these are actually that necessary, like compared to the ones in the sbin. Like mounting and unmounting are pretty fundamental. You need those, but none of these are as critical, I guess. Like to cat a file, right? You can use the underlying write system calls and stuff. Or if you want to simulate for copy, or dd. And if you want to do stuff like or the shells, right? They're just regular user space programs. Sleep, I guess calls some underlying syscall, and these kill commands just these send signals, so they're kind of like nice utilities on top of the base commands. But yeah, I mean, again, you can think of these as pretty fundamental as well. Other things are boot. So /boot is for all the boot related stuff. /boot/default. You're gonna see this is a trend. When you have a /default, it has a list of default configuration files. So you can use those to look at the format of different files. So for example, if you want to look at cat boot defaults loader.conf, you can see you can see a bunch of commands, or a bunch of options related to what would usually be stored in the /boot/loader file. So there's that. There's the dev file system. So if you want to look in here, it has a list of a bunch of devices which are kind of treated as regular file devices. Like these, you can think of these as like special files, but again, in Unix, basically the mantra is everything is a file. So even your devices are treated as special files. If you wanted to do a more in-depth look through that, you can see most of these are a C or yeah, most of these are C devices, which are character devices, rather than regular files. There's that. Slash, okay, that was slash then. Slash etc is for configuration files and scripts. So I think etc just stands for etc, but it's going to become like a place for configuration files. And again, it becomes a trend, so I won't search it right now, but you'll see it. So etc slash defaults, again, like the defaults here, has a list of default configuration files, and you can look at that to look at what configuration options you can choose. Plus etc mail is configuration for extend mail. Plus etc periodic is used for cron. Slash etc PVP is for PVP. I forget what this is. I've never used it. Point-to-point protocol. If you're establishing some sort of connection to a different peer, I believe. Slash mount is kind of empty. It's just used like if you want to mount a different file system. It's just like by convention, people use it as a mount point, but you don't need to make that your mount point. You can mount wherever you want, but it's usually just for temporary testing or administration and stuff. Slash proc is a process file system. It's actually, wait, I'm interested in seeing if it's actually here. Okay, it is. Yeah. So if we go to proc, or if we ls proc, it's empty. Okay, interesting. So I guess by default, FreeBSD doesn't use proc, but I know Linux does. I know FreeBSD uses var for a lot of other stuff, but we can look at man proc fs. And it provides these information, like for example, well, implements a view of the system process table. See, let me look at FreeBSD proc fs. So by default, it may not be even mounted. So yeah, so it says, okay, you see here, FreeBSD does not mount it by default. But if a command uses procfs, like it needs some sort of like introspection tool on the process file system, or like on the system processes, then yeah, so it may be used for the complete operation of some of these tools. I guess I know PS works without like if I just run PS, it'll work. So I guess you don't need proc for normal operation of a lot of programs, but if you do need it, you can mount it as well. But it's interesting. Again, just a little difference between Linux and FreeBSD here. Rescue is for programs for emergency recovery, such as Rescue. I don't really know how to use this, but you can look into that. Slash root is the home directory for the root account. So just like most of the user accounts are at slash home slash the username. So if I do echo home, yeah, it shows my home my home directory. So if I do su and log into the root user, and I do echo home, then I see slash root, which is just as it says. So that's good. Slash sbin we already talked about. These are like the system programs, like the very fundamental administration tools. /temp is used for temporary files. So like when you're downloading something and you just need some space for like some like I don't know, compiled output or like additional downloaded files while you're building something else, you can save the files here. This is not the stuff in temp won't be saved necessarily after you reboot, so it's not for things to be saved. But the nice thing about it also is that if a user creates a file in temp, only that user can delete it, so other users cannot meddle with it. This is due to the sticky bit permission, which is in the file permission section. /user is for user utilities and applications. So this gets a little confusing, and I've been confused about this for a long time. But what I believe is, because you see under /user, you see a bin, you see an include, lib data, lib exec local. So rather than, let me show you. So you also see a bin, you also see a lib, you also see an lib exec here in the root directory, and then if you do ls user, you also see like a bin lib exec. So some of these are kind of similar. Yeah, there's that. But how this works is user is usually for like user installed programs. Most of those go into here. Like most of those go into user bin. So you saw like the bin is used for like the fundamental utilities that were kind of installed already, like the basic shells and stuff. But most of the user applications you install are going to be in user bin, and like the user space, like include files, most of them are going to be in user include, and the libraries to be linked are usually in user lib, and additionally like lib data, lib exec. User local is also similar. Okay, so let's do ls/user/local. You can see another similar file system structure. So you see at these three different levels, at the root, at /user, and at /user/local, you see a bin, you see an include, you see like a lib data, lib exec. So actually user include is supposed to have the same hierarchy as user, but it's used for local executables and libraries. So you can think about the basic one. So this hierarchy, this top level hierarchy, is used for like the most fundamental programs, and most of the time you don't touch most of it. And same with the user, you don't touch most of it most of the time. But when you install some programs, they might show up in there. But actually, the most of the programs that you would install on your own would be installed in /user/local. I believe actually the user file system and the root and the user are actually might be read only in some cases. So most of the time you actually want to install things and do everything in /user/local. And like if we look at what executables are in those different files. So let's do ls bin. We already saw this. So these are the ones in the top level bin. Let's do ls/user/bin. And you see here these are let's less this as well. These are a lot of commands that are really useful, but not at the top level, and I guess also installed by default. And then you also have ls/user/local/bin, and these are the commands that were installed I guess by me, right? When I installed sudo, actually this might be a bad idea, but I can try uninstalling sudo. Actually, yeah, let me do that. Let me log in as root. Let me package remove sudo. Okay, and then let's ls user local bin again, and you see the sudo is gone. So let's do package install sudo, and let's do ls/user/local/bin, and you see like the sudo commands are back, right? So yeah, I guess in a way to summarize, right, we've seen different folders for executables. We've seen /sbin, and these are for the most fundamental system utilities. We've seen /bin, which are for pretty fundamental user like utilities. You can see these at, like, I guess you can think of these as like the shell and like system, like kind of system level utilities, but not like essential for booting and running the system. And then you also see utilities in /user/bin, and these are pretty common ones. And I guess you can think of these as like forming the majority of the. You can see the length. You can see how many programs are here. So if you do ls/user/bin again, like there are a lot of programs here, and there are a lot of user space programs like you see the C++ compilers and stuff like it's called editors, file editors, and utilities to get certain tools, right? So there's a lot here. Make for compilation. Actually, some repeats, like you see pkill is here. It was also in the /bin. But again, a lot of kind of useful utilities at the user level. And then you also see /user/local/bin. So cat/user/local/bin. Sorry, ls, right? And right now, because I've almost installed nothing on my own, there's a little here. But let's try installing something else. Let's do pack install tree. It's a nice little command. And then let's do ls/user/local/bin. And you see the tree command shows up here. So the other nice thing is if you want to see where a program is installed, you can use the where is command. I think there are other commands as well, but where is one possible command. So if you want to look for a program like this very fundamental like mount, yeah, you can see it's in /sbin/mount. If you want to see a program that's like kind of important at the OS level, like the sh command, you can see it's in /bin/sh. It's yeah. And then like, let's say we wanted to look at a program that's like a common user space program that's, I guess, built in kind of to FreeBSD, like G++. Oh, it's not installed. Okay, GCC. That's also not installed. Okay, wait, let's do something like, where is like ifconfig maybe? Oh, that's actually in sbin. That's interesting. Okay. But something like, let's do add user, right? Oh, that's interesting also. Okay, so there's also user sbin, or how about something like get conf, right? Okay, so this is in user bin get conf, or like an editor like vi. This is in user bin. And then if you want to look at any of the commands that we've installed, you can do where is sudo and where is tree. You see these are in user local bin. So I guess I don't have a totally good understanding of those, but that's kind of an introduction to that hierarchy. I'm spending a lot of time on this because it's not totally that clear where the distinction lies. And I know in Linux, actually, I think sbin and bin and maybe user/user/bin are all symlinked to the same place, so it's all a mess basically. Whereas in FreeBSD, they try to keep this hierarchy a little clearer. Actually, I can do that. I can try bringing up my hierarchy. So if I do go to the root here, okay, and if I do this, I can see that bin and sbin are both symlinked to user/bin. So actually everything is in the same directory. So let's go to user bin right? And we see there's a lot of programs here. So, but they're all in the same place in what's called in Linux. They all just kind of get put in the same place. So that's one difference. So again, user local, a lot of stuff will go there in the end. A lot of the configuration you do for like user space programs will all go there, and all the executable files as well. /user/object. This is what happens when you start building your kernel or building your OS from user source. So when you build it from the source files or compile your FreeBSD, I guess. /user/ports. So this is important because I don't know if it's actually populated right now. So let's see. Yes, okay. It was installed during the installation process, which is good. Let's go there. Nice. Okay, so it is here. So what this is a series of user space applications, and we're gonna go into ports later. But what ports are, in short, are like it's like a form of package management in FreeBSD that distributes by source files rather than by binaries. So often what you do is you just like look up like, oh, I'm gonna download Google Chrome, right? So I go to look up Google Chrome, I click on download, right? And I do download, and it'll download this deb file, right? Or Debian. And what you can do is you can install that, and the installation is very quick because it's just a pre-compiled binary. It's compiled for your operating system and for your computer architecture. Assuming so it assumes you're running a 64-bit like AMD processor or AMD 64 processor, and it's assuming that you're running on this system. But what's nice about ports are that it's distributing by source. I mean, there's some bad things about it. First of all, it's not nearly as fast as just downloading from downloading a binary and just running that binary. But it allows you to additionally configure stuff before you compile it, which is nice because most of the time you have like very conservative configurations by people who distribute binaries, and they have to make it so that it works for the general public because it needs to run on many different systems. So if you just distribute a set of source files where it's configurable, you can compile it however you want. That's kind of nice. So this runs hand in hand with the package system. So I showed you to install stuff, you can run package install, and this installs binaries. So the installation process is very fast. But you can use the port system as well as an alternative. And packages installed via ports are basically identical to packages installed via binaries. And once you've installed something via a binary, you can uninstall it using package. Or if you've installed it using ports, you can also uninstall it using package, the pkg command. So really they run hand in hand, and the end result is the same. It's just about how you want to get it. And also, there's a lot of packages that aren't actually in the package that you can't download the binary for. So sometimes you have to compile it from source. Again, the problem is that it takes a while, but it's a one-time thing usually. Okay, so there's and that's another difference from Linux. As far as I know, most Linux distributions, like their default package manager is all binaries. Like I know Arch Linux uses Pacman, and all of its repositories distribute binaries. Same within Ubuntu and Debian using like PPAs and other repositories. So there's and then there's user/sbin. Let me look into this folder, ls/user/sbin, and I guess we can see these are commands that are considered I guess system utilities executed by users, like watch or WPA CLI. So I guess these are like kind of like system administration stuff for users. WPA CLI is for like setting up the network. I'm actually not too familiar with most of these. LP I believe is for printing. Unbound is for DNS configuration. So and WLAN. I guess most of these are for like setting up services like the network. /user/share is for architecture independent files. So like for generic, like doesn't need to be compiled for a specific architecture, computer architecture. /user/source is for the source files. So I think that was also installed during the installation. So go to /user/source, right? I'm looking here. So these are the source files. So if we wanted to build FreeBSD, which eventually we would do if we wanted to build a custom kernel, or if we want to do something like build a jail, which is something that we will do later, then you have to build everything from source, and this is where the source is for the operating system. /var is used for logging, transient, and spool files. So this is used for a lot of like metadata related to your is running on your program. So a lot of times you'll look at stuff like var log, like messages. All right, let me do cat. Right, and we can see the messages related to the kernel. So you can see the messages from earlier when trying to load the basic module and failing because it's already loaded into the kernel. Similarly, there's something called dmessage, which shows the same messages, and I believe they're related. So if we do man dmessage, we can see it displays the system message buffer. And where is this file? So if we look at cat var run dmessage, okay, then we can see so this is like dmessage from just the boot part, and I guess like /var/messages /var/log/messages are similar, but kind of like the dmessage output after boot. But you can see here, this is from just the boot. I wonder if there's just no. So var run, and yeah, you can see there are a bunch of other log files here. I wonder if I look at the sudo. Okay, I don't really know. Var log is also a good wealth of information. See like mail log, messages is what we already looked at, and logs for different programs like cron for the installation program. This is for printing, I believe, and for mail if you want to use the PVP program, etc. So there's a lot of good stuff there. And then var/mail is usually a mailbox file. So when I ran mail, there's nothing in mail right now, but if there were, then it would be stored there. var/spool is for printer and mail system spooling directories. var-temp is for temp files. I'm not really sure what this is used for. But let's see, what is var-temp used for? Temp in the good old days when disk space was limited used to be a different partition. That's making sure the / will never run out of space. Any program will expect var-temp. So it says var-temp is used by vital system processes, and these should be preserved. So it's like they have different like priorities almost. So let's go to var and see if there's yeah, it's just a regular directory. Let's see if there's anything there actually. Oh, for vi. So if I want to cat vi.recover, it's gonna be recover. There's nothing there right now, but I'm assuming for if you're opening a file in vi, and I guess it stores like some backup information, just like if you're opening any editor and it does like automatic backups. I'm assuming this is a similar function. I'll store it in here. That's nice. And then lastly, var-yp. So it's for NIS maps. I'm actually not really sure what that is. Let's look at man-yp. YP NIS is Oh, I think YP stands for Yellow Pages. Network management of password group, net group, host services, RPC, boot params, and other ethers file entries. I'm not really sure what that is, but it says NIS is an RPC-based client-server system that allows a group of machines within an NIS domain to share a common set of configuration files. So if you're sharing configuration files with other things on other computers on your network, I'm assuming that's what this is for. But that's not something I use, but it's good to know, I guess. And YP is Yellow Pages. It also comes up, it came up actually earlier if you see the users, this is interesting. You see it when you look here. There are other commands like YP password, right? Which is actually the same as password, but this is when I looked up YP. So, but if you look up YP, it stands for Yellow Pages, and I guess it creates a different set of like configuration files. And again, you see NIS here. Yeah, let's go back here. I think we finished this page now. Disk organization. So this is talking about mounting, and I also won't go too much into this because it's kind of common knowledge, or at least it's easy to look up. So there's a few things at the end of this page that I'll go over, but in general, what it's saying is you usually have your root file system, and what you can do is you can mount like daughter file systems into directories. So I mean, we saw in the previous file or the previous page that there. Oh, let's go back to the root, and then there is the mount folder, which is usually empty but used as like a temporary mounting place. But you can mount into any directory. Just the mount is used for temporary stuff. So if I like had a flash drive or something like that, you can mount it to mount. Yep. So they explain why sometimes you might want to create multiple partitions, or so they also talk about the difference between partitions in other file systems and partitions in like the Windows sense, which are like physical file systems, physical I guess partitions of a disk, versus what are called partitions in FreeBSD. And I think the distinction is not that important anymore. And because I was looking this up recently, I don't think it actually matters that much, and it's more related to the MBR file system. So if you use the GPT scheme, which I am right now, and I just want to go into yeah, so this is what it talks about, like slices, right? So how do I do this? So if you have one disk, one physical disk, like you bought a hard drive, right? That's one physical disk. It can be partitioned into multiple pieces. So in the Windows sense, you can partition it into what are called partitions, right? And those are called physical partitions. But it says that in FreeBSD, those are called slices. And then you can further partition a slice into what are called partitions. But I believe that has to do with MBR, and because in MBR you can have primary versus logical partitions. So you can have up to 4, I think maybe 3 or 4 primary partitions, which FreeBSD calls slices, and then within the primary partition you can create logical partitions. So, but in the GPT scheme, you're not actually going to see something like this. So this is like, okay, here's the disk name, the number of the disk, and then the slice number, and then the slice number, yeah. And then additionally underneath that, you might have something that looks like the what's called the A at the end, A, B, C, D, E, F. The N indicates which partition under the slice. So you have disk, slice, partition. If you look here, since I used GPT, I'm gonna go to ls dev, right? And if you look, where's my drive? So my drive here is BTBD because it's a virtual, I don't know what BD stands for, some virtual disk 0, so that's the name of the disk. So this is like just the raw disk. And then I have partition 1, partition 2, partition 3, rather than slices. And I think this is because of the GPT scheme. And because I think most modern computers use the GPT scheme, you just have these partitions. And the kind of distinction between slices and partitions is like kind of archaic and not that important. But whatever, like if you see this, that means you're probably using an MBR scheme, and just recognize that it's a little different. Yeah, the last thing they do is they mention the difference between different partitioning schemes. So what you could do is you could divide your file system up into multiple pieces and put different pieces on different partitions, different like physical or logical partitions. For example, if you want to put your var folder, if you want to put that on a different physical partition, that could be useful for things like for performance. If you're using a regular old spinning hard disk, then it mentions that I'm not sure where it mentions it, but okay. Anyways, you can decide to split it up, and the benefits would include you can have different mount options, so you can make certain parts of your file system like read only, because differently mounted partitions can have, or each partition can have its own mount option set. You can also, it says there's some optimization as well. I'm not exactly sure how that works, but I guess if a file system is less used, it gets optimized away or something like that. And then also, if you damage one physical partition, then you decrease the risk of damaging all of your data at once if you have everything on one partition. But again, I'm not sure how applicable this is. Like, if you're gonna worry about something like this, like use something like ZFS and mirror your drives, or use some sort of redundancy scheme, rather than what's called depending on your mounting. I mean, of course, however many ways you can have, like if you can do some sort of redundancy in order to protect your data, that's always good. But it says when you have a single file system, which is what I did, like during the installation process, there was the option to partition your drive. And what I have, I think, is there's a small boot drive, there's a swap partition, which is used when your memory runs out, your RAM runs out. And then the rest is just mounted on the root. So everything else is under one partition, and that's fine. But it says that given that file systems are a fixed size, and say you want to make a partition bigger, then yeah, this wording is kind of unclear. But it says that when you have a single file system, it might be good because you might want to make a partition bigger, and if say it's like wedged between two other partitions, then it might be hard to grow it. And yeah, so I don't know if that's exactly what they're getting at here. I mean, it's always like risky to try to grow a partition, but I think if you have multiple file systems on the same drive and they're all located at certain positions, like sequentially, basically they have to take, as far as I know, each partition is a sequential block of memory, and usually they're just put right next to each other. If you want to grow one file system, you might have to move it if it's like in the middle of multiple file systems, rather than if you have everything in one file system, you can just grow that one partition if you have more space on your drive. But again, this wording is a little ambiguous. They do mention that there's the command called growfs, so it allows you to increase the file system on the fly without worrying about. I'm not sure exactly what you worry about, but it seems like it could be a useful command. So they talk here about the swap space a little bit, and how each partition can only have, or each file system can only be on one partition. And yeah, okay. Mounting and unmounting file systems. So again, this is kind of related to the previous slide, and mounting and unmounting are very common in other Unix systems like Linux. And they said why you might want to put different folders on different partitions. And like I said earlier, you might want to split var from your root partition, but I'm not doing that here. Another reason you might want to do it is if you have a drive that's actually not physically on your system, like a network drive, you can mount it somewhere, so it acts like a actual drive, but it's not physically on your system, right? So if you want to connect to systems that are connected over the network, you can do this. You can mount it like this. But this is what the fs table file, not fstab. I used to think it was fstab. I didn't understand what that meant, but it stands for file system table. This is a list of mounts that are automatically created when you boot the machine. So this is looked at when you boot the machine. So let's just look at an example. If we do cat etc fs table. Okay. So again, the etc is for configuration files, and this top level etc, rather than the /user/local/etc, this one's used for like system level configuration. We can see we mount two things at every boot. We mount the swap device, and we mount the root device, which is type UFS. And the swap, it has a special option called swap, and we can see the regular one is just a regular read-writable device. And they're on partitions 2 and 3. Partition 1 was the boot partition. And you can see the mount point as well. So the swap is like a special form of hard drive space. It's not mounted anywhere. It's not part of the file system. But this is all of our file systems located on this first one. And you can see this dump and the pass number. These are used in the dump command. This is used for the dump command, which is used if you want to back up your whole file system, back up a whole partition. So if you put 1, then it'll be backed up. If you put 0, then it won't be backed up. So you don't have any reason to back up the swap because it's just like temporary memory anyways. And then pass number is chooses the order in which file systems should be checked. So when you're running something like fsck, so if you might have a dirty file system, so like you say you had a power outage, and while you're in the middle of writing a file, then your file system might be dirty. You didn't properly shut down. There might be problems with file system corruption. So you run something like fsck to check your file system and correct new errors if possible. And what pass number does, I guess, is to choose the order in which the file systems are checked. You just set it starts at 1, you set it higher. If it's 0, then it doesn't get checked at all. And it also says if you give two file systems the same number, then they'll be checked in parallel, which I guess is a nice thing. I don't really know why you would want to order them, but I guess you could do this. And then to actually be able to mount a device, you can use the same syntaxes in like Linux. Again, very common. I'm not going to go into that. Same with umount. Okay, this is a fun chapter. So, like the basics of any operating systems class, you talk about processes very early on. Processes and daemons. I actually don't know if this is supposed to be pronounced daemon or demon, but I mean, they talk about how the BSD mascot is a cheerful demon with sneakers and a pitchfork. Not familiar. It was the same thing as in the FreeBSD loading screen. Let's see logo. Right. I mean, now it doesn't really look. Okay, this is what they're talking about. It's very cheerful. And the term comes from Greek mythology and represents an entity that is neither good nor evil, and which invisibly performs useful tasks. So demons. Okay, so this differs a little bit from like I believe the Christian like interpretation that they're usually evil. in Greek mythology, I guess it's more neutral. You just kind of do things. And I guess to back up a little bit, a process is a, like, you can think of it as like a thread of execution, or a program usually. One program that's running. You can have multiple programs running at the same time, right? I have multiple programs running at the same time. I have this emulator, which is running many programs inside of itself, and then I have Firefox, which probably uses multiple processes as well as like the GUI, which is a process in itself, and like the network based stuff as well. So there's a lot of stuff going on. But so each process has its own process ID. It has its own user and a group, and most have a parent process started. Again, this is like OS basic, so I don't want to go into this too much either. There is a special process called init, which is the first process, and it has PID of 1. And again, this is different from newer Linux systems, which use the systemd system now, which kind of replaces init, and it spawns a bunch of processes on boot and services. So init was the older system, and it's still used in FreeBSD, and it's simpler. So this is the first program that gets run, the first process that gets run, and it spawns other programs as well. So it distinguishes like processes from what are called daemons, or I guess it says daemons are a specific type of process that are usually used as, like, you can think of them as like server processes. They're not always at the front. They're like doing things in the background. They're processes running in the background. So examples that you say like are a web server that's listening to web requests. Right? You don't have to continue to interact with it. It's not like always at a terminal waiting for your input. It's just it could be waiting for other stuff, but it's like running in the background. And often they end in D, like the letter D. So the printer, right? LP is like the LP process command. The name of the daemon is called LPD. For the bind DNS system, like the process, like you can think of it as name, right? But it's called named. This is just a convention though, and it's not there for everything. Like it is for HTTPD, but not for sendmail, which is just called sendmail. So in order to view the processes, you can use there are two built-in commands called ps and top. So ps lists the processes that are running. You can see here there are 7 virtual terminals, the login shell, and then the shell. Right? So these are just the user space. These are just the processes that I as a user am running. But there are additional options. They mention here some common commands, AUXWW. So if I do something like AUXWW, right? And I get a lot more options. Yeah. So this gives this, when you do A, it shows all processes of all users. So not just like my only ones that are spawned by my user. U displays the username and memory usage. I can't really see what they are right now, but if I wanted to. Right, so yeah, you can see the PID, the CPU usage, the memory usage. So idle means that the CPU is like completely idle right now. It's like none of the memory is being used, etc., etc. And the X says show the daemon process as well, so not just ones that are created by normal users, but processes that are created by daemons. So like you see DHC client, or let's look through this. Like send mail, right? There's this process for the mail client, and there's like NTPD, which is running in the background. Like it updates the time, make sure the time is synced up. SSHD, to allow incoming SSH commands. Again, you see these are postfix with the letter D, or suffix with D, because they indicated daemon. Compared to some of the things I'm running, like less and ps-aux. Right? The other command that's common is called top, and it's a little simpler, or it allows you to see things a little easier. It updates every like second or two, maybe every 2 seconds by default, and it shows you commands, CPU usage, and like other things like priority value, which deals with scheduling, the user that ran it, the PID of it, how many threads it has. The interesting thing they point out is, well, okay, also the state of the program currently. So, like a terminal command might be, I guess this means like a terminal that's waiting for input. Like there's pause and select. I'm not exactly sure what all these mean. Top is the currently running command on the CPU. I guess NTPD was just running for a second there to show that it was updating with the time, making sure the time was synced up. Yeah, but here these two indicate the memory. So size indicates how much memory this program has fetched total. So every time it allocates memory, I guess it adds it to size. But resident is like the current size. So how much memory it's currently taking up, resident memory. So this is like currently taking up 7 megabytes of RAM, for example. Top is currently taking up 4 megabytes, but in total it's fetched 13 megs. A very similar command is something called htop, and I will install htop. Yep, okay. So let's do man htop, and it says interactive process viewer. It's similar to top, but it allows like scrolling and also has colors. So let's try htop. So it's a nicer thing. You can like scroll through these and scroll horizontally as well. You can search. So if I try, I can search by command. Like I can search top, right, and it gives me an htop command. You can also sort. I can filter. I can sort by different processes. I can change the nice values, and I can send signals to them using kill. So there's a lot of stuff in this command, and it's nice. It updates pretty quickly and all that. The other thing you can see here is there's a graphical representation of like the CPU and memory usage as well as the swap usage. So I'm not using any swap right now, kind of as expected. I'm only using 200 megs of RAM, which is puny. But again, there's not many processes running at all, and I'm like not using the CPU at all. So like you can see, it's pretty lightweight, this base installation. Granted, it can't do that much either, but because there are not that many packages installed, and not many things running, but it's showing that the base configuration of FreeBSD is pretty minimal. Yeah, so there's that. It mentions you can kill a process by sending signals to it. So this is again a common thing in Unix systems, something called signals. So kill is used to send signals. It doesn't necessarily kill the program, like despite what the name suggests. I mean, that was kind of the original purpose, but it can be used to send any signal, which can be just used as like messages. It could be used as a form of passing messages to a program, to a process, but usually it kills a process. I guess just to quickly demonstrate that. So say I'm doing htop. Say I am running htop in here, right? And I switch to a different shell and I log in here. So I just did Alt F2, and I do ps-aux grep htop, right? And I see htop is running somewhere. The root is running htop elsewhere. And it has a PID of 1763. So what I can do is try to kill 1763. And if I run ps-aux htop, you only see the command that I just ran, which was trying to look up htop, and it's gone. The htop is gone. So if I go back into the first shell, so I'm gonna log out here. I don't need this anymore. Go into the first shell, you can see htop got killed, and it's kind of hard to see, but it got killed. It wasn't updating anymore. Okay. yeah, so don't kill random processes on your system. That's probably bad. So make sure you're killing the right program. So one way to do that is using the pkill command, which allows you to kill a program by its name rather than its PID. So if I wanted to do something like, I could have done pkill htop instead, and that would have had the same effect. I'm not going to do that. No. Okay, shells. So this is again OS Basics. Not a bad thing to review though. And what a shell is a command line interface for interacting with the operating system. So if you do something like echo shell, you can see what exactly is the program that you're using right now. So there are different shell programs, and each shell program has the same similar goal, which is to interact with the operating system. So it's literally just a program. So if I wanted to run it, I could do something like bin sh, and I switch shells, right? Now, I think I'm still using Siege. Interesting. But if I log into John, which actually does use I believe uses the sh. Yeah, it says it's using /bin /sh. So there's that. There's features such as autocomplete when you do tab. So if I want to do ls / I can do tab, and it will show me some options. If I start typing something like bin, and I press tab, it'll autocomplete it. That. Then there's something called environment variables, and these these are configured by the shell and managed through the shell. What you can do is do something like echo and then the $, the configuration, and then the environment variable name. So something like echo user is John, echo path. Path is a special environment variable that says where to look for binaries. It's the same as in Windows. And you can see here, these are basically the list of all the bins, right? All the binaries folders that we were talking about earlier when we were talking about the hierarchy. There's /sbin, /bin, /user /sbin, /user /bin, /user /local /sbin, /user /local /bin, and there's also home/john/bin. So if I install something in my home directory, which I believe is kind of rare, I can check if there's anything there. Oops. That's what I want to do. That was bin. Oh, actually, it's not created, but if it were there, it would also search that directory. So, but it's a kind of a non-default location, kind of a strange location. I mean, there are also other interesting ones you can look at. So there's you can do echo display. So this will not show anything right now, but this is used by a GUI. You can do echo shell, which I've already done a few times. Show which shell is currently being used. Echo term. This shows like the name of the type of terminal. So sometimes you have different terminal emulators, which is like a program that runs the shell. So I can show you on Debian. This is one terminal emulator. If I do echo term, this is xterm. Versus if I try to run a different terminal emulator like xfce4 terminal. Actually, I'm not actually sure if this will work. Yeah, if I do echo term here, this is emulating xterm but with color, for example. And you can see it has a different name here. And the different name indicates the type of terminal, which can be used to determine the capabilities of the terminal, and so different functionalities might come up if you have a different term. If you want to do echo term cap, this shows a list of escape codes. There are none here, but they're not here either. Yeah, okay. So I don't actually know what this is for. There's also type of operating system, so I can do echo OS type, and that doesn't work. Okay. I guess this depends on your editor. Let's try echo machine type. Echo editor. Okay, so at least editor is set. The default editor is vi. Echo man path doesn't have. Okay, that's okay though. Some of these are not set, I guess, by all. These are just the list of common environment variables, but they're not all set here, at least in sh. And if you wanted to set some environment variable, you can do something like this. You can do export or yeah. So I'm using sh, but it's yeah, sh and bash use export. So if I wanted to set any, I mean this is just bash syntax. If I want to set any variable, I can do in general, like say this variable called v or var equal to hello. Then I can do echo var. It'll give me hello. But I could do the same thing to any of these. Like I could do echo let's do editor. Sorry. Let's do export editor is equal to vim, right? Okay, and then I can do echo editor. I mean, granted, vim is not installed. I should probably install it at some point, but okay. But I think vi is fine for now. Actually, let me change it back to vi. So then what you can do is stuff like this. If you just do editor, it'll open the editor, right? Or if I want to do editor and then like a file like hello, then I'm editing a file called hello using vi. If you wanted to change the shell, you can use the change shell command in FreeBSD. So change shell. Actually, this doesn't allow you to only change the shell. It allows you to change your other information about your user. Remember that the shell is part of the it's associated with the user, but so like this is your default shell when you log in. I could change this to something like bash if bash is installed, which I don't think it is. Try bash. I could do something like install bash, but I know there's also siege. So you see the command prompt changed when I changed the shell. Yeah, but it doesn't actually change the shell variable. But change shell, you can also use the -s to change the shell by default. Here are some advanced shell techniques. Oh, it calls this advanced. There's notes about. So this is called file redirection. This is also file redirection. Here's file redirection both ways, and you can also redirect to standard error. And then there's something called piping between programs. So what file redirection allows you to do is change the import or output like standard files for a program, for a process, and then piping allows you to make the output of one program the input of another, and then the output of this program will be the input of this one. So it's good for chaining commands, which is very common. Granted, there are a lot more, I guess, advanced shell techniques, and it really depends on which shell you use exactly. Different shells have like different syntax. Bash is very common for Linux users, and it's a whole scripting language, so you can do a lot with it. Text editors. Okay, so here brings up. This is just a short thing. Most FreeBSD configuration is done by editing text files, because most things there's a lot of configuration that's just simple text files. EE is one example editor. I don't use this that much. I know it's different than like, well, you can look at, this is what it looks like, right? And it's very simple. You can type whatever you want. And then I press escape to leave the editor. Let's see if there's Nano. So Nano is not installed by default. I think it is installed by default as like a basic text editor in many Linux distributions. But VI is usually installed, so you can use that. You can install Vim. You can install Emacs, but I'm not going to install them. I'll stick to Vim for now, or VI for now, because it's easy, very simple. And then again, because it's set to editor, you can just call it editor, and this will open your default editor, which is VI for right now. Okay, devices and device nodes. So we already saw this file, var run dmessage boot, when we were exploring the var system and exploring dmessage. But a device is a term used for hardware-related activities in the system, including disks, printers, graphic cards, and keyboards. And when you boot, the majority of the boot messages are referring to detecting these hardware devices. So again, if we do ls dev, you see all these different devices. Okay? So like PCI devices, or like if we have USB devices, I don't know if any of them are here. I guess they'll show up if we plug anything in. And then like virtual devices, like terminal devices, are treated like devices because they have like input and output. Oh, USB here. These are the hard drive devices. Memory, the keyboard device. This is, I believe, the installation disk, DA0. And additional to other devices. I'm not exactly sure. Again, these are other ones related to the keyboard. I'm assuming there's one with the mouse. Maybe not. Yeah. But each device has a device name and number, and you can see them in dev, which is what we're seeing right here. So, and again, it mentioned the dmessage rate. So if we do dmessage, I mean, this shows the whole dmessage log, but if we just want to do cat var log, or sorry, var run dmessage.boot, you can see it's also less this. We can see these are the list of messages that showed up while we were booting, and you can save to this file. So if you have problems when you're booting, you can look at this file and revisit those. Okay, manual pages. So this is this is the last section in chapter 3, and I'll probably stop after this because it's been 2.5 hours. So the manual, the most comprehensive documentation of FreeBSD is in the form of manual pages. So I've already used this a bunch. So you can do man to see the manual page for man, and it allows you to it shows what man is used for. But in general, man allows you to see the manual page from any command that has its manual page. And you can see here there are different what are called sections of the manual pages. So some commands may appear in multiple sections. For example, the printf command, by default, it goes to the first section, which is a user command. And like these user commands are used like for shell commands. These are like shell commands. So if you use printf as a shell command, this is how you use it. Versus since I'm sure, or I assume most people know that printf is also a C function. But the third level here is for functions in the C libraries, and this is its own section in the man pages because C is so prevalent in the OS in Unix systems. So if I do man3, so you can do man and then the section name and then the command name printf. It shows this is the you can see FreeBSD library functions manual now. Before it was something different. And this is how it gets used in the C. It says, oh, you need to include stdio, and here are all the usages, all the parameters. There are a lot of variants here. But if I looked at man1 printf, you see this is the general commands manual rather than the library commands. So there's also system calls. So again, OS topic system calls are pretty fundamental for giving control to, switching to a super user control, like being able to deal with hardware and stuff. You call system calls. 4 is for device drivers. 5 is for file formats. And I think this is a little confusing, but it's saying like when it says file format, it means like for a configuration file, what should it look like? Like I know I was looking at this one recently, source.conf, which is for when you build the source file. You can see it's in section 5 for file formats. Similarly, you saw there are other ones like let's see if fstab is here. So if we want to do man fstab, yeah, so this shows up here, right? And usually, like, because it's a specific file, you can see where it appears. Does it say etc? Yeah, so etc fs table fstab, right? So it tells you where the file resides. So that's useful for a lot of configuration files. But also, again, the configuration files you can find default in like something like, if it's etc fstab, then you can usually find it in etc default fstab. You can find examples there. Actually, let's look at that file. Oh, it's not there. Okay, so there's no defaults for that. But if you have, again, I saw the boot. So if you have the bootloader.com, you can look at boot defaults loader.com, and this will show you example commands. Or a very common file is if you want to edit rt.com, the defaults for that would be defaults rc.com. Okay. So actually here there's a lot, because there are a lot of possible options. So very long file. And then games and other diversions. I don't know if I've ever used this one. Miscellaneous information. I think this one, like, let's try this. Man signal. Oh, man 7 signal. Okay. Well, I'm not sure exactly what comes up in the 7th section, but it's for miscellaneous information. 8 is for system maintenance and operation commands. I think some of those have already showed up. I don't. Let's try man dump. Right. So this is in section 8. It's used for system administration. I guess it can come up maybe as a user command, but I guess these are for like a lot of the things that come up in sbin. Let's try, like, I know mount is in sbin, so let's try man mount. Yeah, this is also 8. Let's see if ifconfig, right? Yes, where is ifconfig? It's in sbin. So let's see if it, let's do man ifconfig. Yeah, this also shows up in 8. So I guess a lot of these are for like system commands, the sbin commands. And then 9 is for system kernel interface. And on top of my head, I don't know what is in there, but I guess the name is pretty self-explanatory. So if it appears in more than one system, then you could do man and then the number. So we already showed that with printf. So chmod is similar. It can show up in both section 1 and 2. You can also search it. I'm not going to do this right now, but you can search the man pages for a command. And sometimes it's useful in case you forget what the command is. So this does like a keyword search, which is kind of nice. So if you want to search any command related to the mail. There's also the command called apropos, and this is probably easier. So let's look at what apropos does, right? Search manual page database. So it's really easy. There's also a command called whatis that is similar to apropos. So we can try both those commands. Let's try apropos mail. And this finds a bunch of commands related to mail, like let's say like send mail, which might be what we're looking for, or like, I don't know, aliases, which is something to help configure send mail. We can also try what is like mail, and this, I think it just searches for mail in the name. I don't know, it's a little different, but I think I often use apropos because to get more results. And then the last thing it mentions here is there's a command called info, which is something that was invented by it was created by a different organization, or I think man pages are much more common, but info pages were supposed to be a replacement of man pages and be more better. Like they usually have an examples section and they're like hierarchical. So if we try something like info man, info is not found. Okay, maybe I have to install info, but let's see if I can do man info. Okay, but if I install info, let's actually do that. Package install info. Sudo package install info. Forgot I was logged in as John. Oh, let me actually look it up. FreeBSD info is not installed. FreeBSD or actually it might be a port, so package can't find it. Let's go to cd user ports, and this is a preview to the ports. Let's do make quick search. Oh wow, okay, never mind, I'm not ready for that right now. So yeah, so let's just I guess that's enough for today. But info in general is like man, and I guess you can install it separately. Right now my ports are not set up from this base installation, but you might be able to install it from the ports. That's what I'm assuming. And yeah, so it's been 2.5 hours. I hope well, again, this was mostly meant for my own documentation, learning the FreeBSD piece at a time, but I hope it has helped someone else. And yeah, I'll try to continue doing this. So this was the first 3 chapters.